Thank you. Hello, everybody. My name is Justin Castilla, and observability is for the front end too. So how many people were here earlier in the previous talk? Fantastic. Like, that was an amazing talk. And I'm so gladdened that I can actually kind of zoom in on one little portion that you didn't cover, which is great. So high fives there. So yeah, I'm going to talk about the front end, which I've noticed that I haven't really touched upon when I've been working on observability, and I've noticed a lot of other people haven't really touched upon. Oh, let's talk about that a little bit. But first, who am I? I'm Justin Castilla. I am a developer advocate at Elastic. Elastic is a data platform vendor. We are freshly back to being open source, so I am very happy. I sleep better at night. My beard has grown fuller and richer. It's still gray. But yeah, I'm very happy to announce that and actually have that back. Previously, I worked at Redis, which is now closed source. That's why I'm no longer there. But and then I was also an engineer at Sauce Labs, web dev bootcamp instructor. So like teaching and talking is just kind of like my thing naturally. At home, I woodwork, I rebuild vintage synthesizers, and I spend way too much money on these two guys. There's Frank and there's Doug. They're natural poses. So this talk is aimed for developers who have some experience with observability or have seen the previous talk, which was a fantastic primer for this one, but haven't worked with browser implementations. So the whole goal is to have like one big overarching surveillance or reconnaissance of your spans and traces and metrics and logs. And browsers they aren't really immediately intuitive how to actually interact with them with observability. So I kind of want to talk about that. And then this talk and all the supporting code is in this repository. So you can take it. Please feel free to use it and see just sort of the wackiness that entails actually running this in a single app.js bundle and served with your HTML file. It's kind of hairy. All right, so what are we going to talk about today? What is observability? Why am I talking about it in the browser? How do we do it? I'm going to talk about manual instrumentation, automatic instrumentation, and then fine-tuning that sweet spot to get exactly what you want and not what you don't want. We'll see a little bit of a demo, and we'll do a bit of a recap. Okay, so what is observability? It's the collection, aggregation, and dissemination of telemetry, which is metrics, logs, traces, things that naturally occur within your application, and also profiling, and then compound it into one singular source that you can actually take that data, rearrange it, create some new insights from over time. Reveals pathways and timelines of processes as they travel through your code base. So I've been working a lot with observability in the back end. I am a data platform, a database enthusiast, so I play a lot back there. But it is also very important to think about our actual user across the world on a browser and what they do. So I wanted to kind of finish that education and the exposure for me to actually build some browser integration. So front-end latency, unknown delays, unexpected quirky behavior. You click something and then the drop-down drops down a second and a half later, or there's like a weird, thinking circle icon that just sits there forever. We want to know what causes that, right? And observability can help. There is RUM. After our talks, there is RUM. Real-time User Monitoring. And that can actually boost your UX updates because you can actually see how the websites are performing, and it is a thing that exists prior to observability, so that actually works well with it and blends perfectly. It's really amazing stuff. We'll talk about that a little bit. Okay, so this is a very, very fast and dirty little a map of how the telemetry works going from your browser. The browser with app.js creates metrics and traces and logs, and then it sends it to a collector. That collector either alters that data or compounds it, and then it sends it off to a data platform. Now, a trace is a record of the end-to-end path of a request through your application. So showing different components and different services that you call. So a user clicks on login, that serves them a portal to actually log in with, say, OAuth. That call to OAuth will come back, and then once they're logged in, they might pull up a user dashboard. So that's going to be, potentially a few database calls. All those different things are going to happen just for that one single user to look up their saved recipe or whatnot. That's a lot of different metal that it's tickling. So we're going to actually want to see all of those things to create a longer story of, what is taking a long time, what is taking a short time, what could be improved, what are some bottlenecks that are happening. So that's a trace, and a trace is a subset of spans. You can almost think of a trace as an entire train holding 50 to 60 cars, and the span is a single car within that train. And spans are what we watch and record to create one big trace. Here's an example of just a simple click on my front end that I gathered. I clicked, and that triggered an HTTP GET request. So this whole thing here is a span, and we have parent spans and child spans. And this can get absolutely, this waterfall can just go all the way down to the ground of different calls, and that's usually what you see. This is actually an example of Elastic. We have an observability pillar of our platform. We're data storage and we're database. We're search, basically. We're Elasticsearch. But we also do really well with observability because we've been doing things like storing logs for years with Logstash. So this is an example of a larger waterfall. So you see up in the front, there's an HTTP GET, and that just triggers all these different GETs, all of these different endpoints, and then all the way down here, we'll have, you can't really see it, but that's a database logo. So we're actually going into the database, and you can see what calls are being created within this database. There are a large amount of companies and vendors, databases that are compatible with OpenTelemetry, and so we can already tell what they're doing. So that's really, really nice, like MongoDB, Redis, Postgres. They're very friendly, and they have integration with OTel, so we can actually see what's going on. Okay, so observability implementation in the browser. Integrating traces and observability in the front end. We have to use, of course, the OpenTelemetry package, and then we'll just include that in app.js. I wanted to keep this as simple as possible. It was very painful in that process. So it's really easy to get observability running with Next.js or Django, or with Express and Node.js serving into the front end. That's great, but I really, really, really wanted to focus on just the browser and an app.js. How far can I get? This isn't exactly what you would do in production, but I wanted to see how much I could push that front end JS to see how much I can gather. And it was really interesting. So yeah, we have Node.js implementations, we have Next.js and React integrations, Django and Flask. I have another developer advocate who's working on a fast API implementation, which I think would be a really good congruence with this one. So this is basically the path a little bit more expanded as far as how we actually did this within this code sample. So I wrote the OTel code in my app.js, which handles the document manipulation, click handlers, and things like that. I had to send it to a reverse proxy. The trace requests hit cores. Now, I've been playing with databases since 2020, and I came back to the front end maybe 3 months ago. I missed cores so much. So yeah, this reverse proxy basically responds to the pre-flight of the cores with a 204, and then attaches the headers to those trace requests. This can be dealt with an actual Node.js or Backend implementation of OpenTelemetry to help. Then I send it to an OTel collector, No-tail collector takes that data. You can manipulate it if you want, and you can send it off to your backend if of your choice. So for me, it would be Elastic. But again, you can use anything, and you can take my little logo up there and replace it with whatever you want, Prometheus, Grafana, Snowflake. But I mean, she would be nice if you thought about Elastic. Okay, so this is the bare bones implementation of creating a span in JavaScript in my app.js. So remember how I was showing you that waterfall where you have parent spans and child spans? I wanted to grab that parent span if it was active, if there was one. If there was one, I wanted to say, hey, I want to be a child of this parent span. So here, oh, my height's actually coming in really nice here. I'm creating a new span called span name. That is now a point within my telemetry where I can add data. So, you know, what page is this? What interesting data points from the user for my specific use case do I want to store? Things like that. And that could be a string or a number. It'll take those two apart. Here, I can actually set within this context of me being the child of the current parent, I can set data. So some key has some value. And it's just key value pairs that are stored within my telemetry. Now, this is a happy path. If there are errors, I can also do span set error or record error. And that's also a fantastic way to debug. And I was actually using this to debug my old ancient front-end JavaScript. So I was eating my own dog food like day one, which was great. And then, of course, just a little housekeeping to end your span. Otherwise, it'll just keep on going. So this is a one-and-done child of that parent, and it will end, and the context will go back up to my parent. And then here it is. I would write that code that you saw previously where that magic span logic goes. And this is just a query selector for a button that had the example ID. And it's that simple. It looks that simple. I think it's on its last legs. Okay, so that's manual implementation. But I don't want to write all that code. That's a lot of implementation of span and telemetry. What if I had a very large website that had a lot of high interactivity? What if I had a lot of information that I wanted to record? I would have to create basically a shadow structure of all my interactivity in telemetry, in all of this span creation of children and things like that. To kind of give it some kind of context, do you ever remember that bodies exhibit back in the early aughts? We'd have these bodies. This was a little grisly, but it was really interesting. But you'd see like the musculature or the bones, but then you'd also see like the nervous system. I kind of feel like implementing manual spans throughout your entire application would just be creating this like little dendritic nervous system next to the muscles of your website. So it's very, yeah, I think it's a lot of work. Also, if you're updating, you have to update your spans if you're updating your code base. And then it requires just a lot of planning, a lot of tracking, a lot of taking what your parent has down to your child and vice versa. So I'm a developer. I am not tired. I don't want to work. I don't want to work that hard. So automatic instrumentation. Now, automatic instrumentation is just like it sounds. You set it and it automatically starts tracking all of your activities. So all of the events. So if I click on a button, it'll cover click. If I move a slider, it will do that. If I input text, if I do all these different things, if I create GET requests, it will show up as a span. If I, like, everything is basically in there. It's not going to collect all the data. So user inputs, things that you have important to you as your company or your application, like those interesting data points, that's not going to be collected just because automatic instrumentation can't do absolutely everything. But it collects a ton. And I'll show the larger boilerplate to actually get this running, but for this instrumentation, you just register it, and you say, new get web auto instrumentations. And it's just that easy, which is really, really great. But you get a lot of data. So you're just going to get a huge amount of data at you at all times. So if you start getting hugged to death, if your product is amazing, you're going to see a lot of repeats of what you already know. And so that could actually be very expensive. That could be hard on your system. That could clog everything. And that's exactly what you don't want with observability, right? You don't want it to be an actual problem to actually compete with your performance. So automatic instrumentation is great, but you gotta pull the reins back a little bit. What if I didn't watch every single load? What if I didn't watch every single GET request or anything? If I wanted to kind of pick and choose what I wanted to pull back. Well, you can. Auto Instrumentations Web, the NPM package for OpenTelemetry, contains these 4 packages. Document load, which creates logging and traces for your loading of your actual site. Instrumentations fetch, which focuses around fetch. User interaction, so click, slide, drag, hover, let's make international hand symbols. And then instrumentation XML HTTP request in case you wanted to do one of those. You can pick and choose now what you want to actually have. So I can just want, maybe I just care about document load times. I can integrate that and not load any of these. And that's already some savings. And you'll notice that these are all, these are constructors, so I can call them with options, which is really great. So here I am. This is a little bit more of a pulled back, reined in version of automatic instrumentation. I have, I'm registering the get web auto instrumentations constructor, and I'm passing in, I want instrumentation fetch to cover my fetch requests, and then instrumentation user interaction. Specifically, I want to monitor the click events. And that will create events, OTel events around click events. And I can pass in any other argument that I want to monitor. Now, within this instrumentation fetch, you'll see that I'm passing in apply custom attributes on span, automatic span method. That's me actually taking that automatic span and saying, this is great, but I want to add my own manual data to every single time you call a fetch observability span. So what if I want to pull out data from that fetch? What is the user input? Where are they from? What are they searching for? Things like that. Things that matter to my business logic, I can actually pull out. Automatic instrumentation does not do that automatically because they don't care about the data that they're sending back and forth. They just care about telling you what happened. And that method that I called automatic span method, it is an interface, and they just give you the span, the current span, which is the child that they created for you, and the request and the result of that fetch. So that's really nice. That's actually really cool because you can pull out responses from your backend, and you can actually check out the request and see what the request parameters are. So if somebody was searching for weather in Bellingham, you can search is it a zip code? It is just a string of Bellingham? Is it a string of Bellingham, Washington? Things like that. And then you would just write that code that you saw previously of me working with the span, set attributes, stuff like that. You just put it in right there. So it's not too impossible to actually get this up and running, to pull in and rein in that automatic span creation. Here, I actually learned about, I'll expose my ignorance as a database nerd, about the need to clone requests and responses when you're dealing with them with a fetch, because it's a promise, and once a response is touched, then it's just over. So I have to clone everything to actually inject span information. That was just for my own interest. And I kept on seeing these weird errors in my spans that I was getting in Elastic. So I was looking through all of my span creations, and I was recording errors, and it said bad body or like body already used. I'm like, I'm out of shape, but come on. But yeah, so that actually helped too. So again, eating my own dog food to actually get this application up and running was really helping me learn about front end. So I was talking about this one argument, apply custom attributes on span. There are other options that you can actually pass in and create custom functionality. You have ignore URLs, so you can actually whitelist, or I guess blacklist, different URLs that you don't want covered. We have a request hook, so you can go simply into the request before it actually gets sent out. That will trigger its own actual function. Ignore network events. If you really wanted to cut out a ton of your automatic implementation, ignore network events. And then measure request size. So that's also really good to calibrate and kind of think about the performance of your front end, looking at the actual request size that is being sent to the back end. And that's just something that you can Boolean just flip on or off, and that'll be included in the data that is sent to the back end. Okay, now this is actually really cool. I got this information on Friday, and I was driving up here from Port Orchard, and I was like, oh, that's awesome. I'm not going to work on that right now, but I did work on this last night. So I can't go into this too much, but basically, we have a Web Vitals instrumentation. So you saw that instrumentation fetch, that instrumentation user interaction. Well, now we have Web Vitals. Now Web Vitals are part of RUM, Real-Time User Interaction and Monitoring, that kind of measures these different metrics that have been accepted upon and agreed upon by the community at large. They're created by Papa Google, and there's LCP, CLS, and IMP. And these actually kind of make sense. The largest content paint is how long it takes for the largest document object to load into your front end. So that could be the paragraph, the annoying video that plays in the background while you're trying to navigate, the overly complex, UI. When you scroll down, it actually scrolls to the right. For example, but then I love this, cumulative layout shift. You go to a website to learn how to make focaccia. And you're looking at it, you're reading that long story about how focaccia is great and how they learned from their grandparents, and all of a sudden, bam, get auto insurance. That's a shift of the layout, right? So this is actually measuring how much that's happening, how much it's jostling my comfort, and ultimately how much it's jostling my delight of that web page. And they can actually measure that now, which is fantastic. And you can dive into these, like all these underlines, those are all links. And then if you look through this repo, I'll have all these links that you can click on. And you can actually read up on RUM. And it's very interesting stuff. And I really appreciate, as a database nerd, how they've kind of removed a lot of the qualitative and a little bit more of the quantitative in this case. And then interaction in the next paint. So how responsive is the website? So I clicked on something, or if I hover over something, and then it loads down. It does that drawer pull down? If I have to wait over a certain amount of milliseconds, I'm gonna get really annoyed because I have the attention span of a fruit fly at this point. So that number is also a really important number to track and give to people that are working on the front end and marketing and things like that. So if marketing wants a big push of this new brand, you're like, this is killing our front end. You're choking it to death. They're like, okay. So that's really cool. And Web Vitals is available into OpenTelemetry. I was doing a lot of research on how to check a lot of information on this as an existing package, and it doesn't exactly exist. Honeycomb does a really good job, but it's in the walled garden of Honeycomb's package, so you have to pull down Honeycomb and things like that. Everything on my front end in App.js is all open source and it's all completely available. It's just all from OpenTelemetry. So I wanted to, again, keep within those rules. Our Web Vitals instrumentation was set up and written by my supervisor. It was pretty awesome. Oh, this is ridiculous. This is amazing. I'll give it a try. Hope it doesn't break. It didn't. Okay, so that was the front end of all the different things I integrated. And then I set it to my Nginx reverse proxy. Did anybody attend that reverse proxy talk yesterday? That was really neat. You know I'm going to try it. I don't need to for this use case, but I'm definitely going to try that. So yeah, it just listens to incoming traces from my front end. All it really does is just takes care of those CORS headers. The Honeycomb package does tackle those by actually having an option that you pass into the SDK to mimic your server target, but I suspect that it's basically doing this under the hood, but I can't exactly comment on that. And it basically takes that new headered request and it forwards it to our collector. And I have the reverse proxy and the collector running as containers just right next to my application. And yeah, the OTel collector receives telemetry data from the browser. In this case, it's HTTP. And it can do any kind of transformations, normalizations, things like that. And then you can actually send it to a data platform, one or more, and it uses the OTLP protocol, or OTLP, OpenTelemetry line protocol. And that's basically HTTP. You can also send it with gRPC through the backend, like Node.js, things like that. But you'll see in most collectors they have options, HTTP or gRPC. This is nice because it decouples instrumentation from your backend observability. So this is just front end going to a collector, but you would also use that same collector most likely with your backend as well. And it's just something that's decoupled, so you don't actually have your observability server or solution sitting in your entire service. Yeah, it's just nice to keep everything separate. And then the data platform. And these are just some things that you would probably want to have with your data platform. So it stores it all, everything that you want. You can search through it. You can search through your history. It's organized. You can create dashboards, alerts, anomaly detections, things like that. And expose an API for extended use of telemetry, hooking up to an LLM, things like that. And yeah, current technologies, open source technologies solve this. Grafana, Prometheus, Dynatrace, ClickHouse, all of those. Elastic as well. Take a look at it. It's open source, and we do all of this and a little bit more. So, but I'm talking about OTel. Okay. So let's look at a little bit of this fantastic website I made. So, are you guys ready? I haven't touched the front end in 5 years. There we go. So again, was that?
It's functional.
Yeah, that's exactly.
I mean,
yeah.
what you needed to do.
I did use a little CSS. That was fun. I'm very proud of myself. All right, so this is my little like Rube Goldberg, like that play board that you give children nowadays, like knobs and things to tweak. And I can click on one of these. I'll create a manual span right there, and I'll see manual span user.clicked. And that's the ID, button 1, emitted. I can look in the source, or no, network. And I can look at the traces. These are the traces that are sent out. And then I can actually see in my request, this is an actual trace that goes to the backend, to my collector. And there we go, user clicked button 1. That's a string value of an attribute I set. I set 2 attributes, action, and the value, user clicked, and then value, and whatever I want to put in there. And all of these different actions here create those, but we'll just start with the manual span. Now this is the, let's make this a little bit bigger. This is the interaction for Elastic. And again, this can be, you could consider this an agnostic talk, but I just prefer Elastic because I'm kind of good at it now. So I'm going to click on this, and I can learn information. How fast it loaded, the actual average throughput of my systems, there are any failed transactions. And now here we go. This is the actual trace, and then I can click on these and gather some information. So I'm going to click on this parent trace, and then I can see user clicked button 1. The label was hash button 1. This was me creating a manual span. Okay, so this is not automatic. This is just me doing hand-coded implementations. And then all of these things are included as well. So what package was used to create this, the WebJS OpenTelemetry package. What server is watching it, so the APM server. And then we can see the transaction service name, which is vanilla front end, the whole encompassing name of what I'm using. You can say like the observability campaign name if you want. And then here are two important things that a lot of data platforms are watching, the span ID and the trace ID. So that trace ID is going to have a lot of span children, and that's going to be collected, and that's going to be collected as well. And then just some more basic information. I could add as much as I want too within this label section. That's going to be creating my manual spans. So that was the user click button 1. In my code, actually, let's look at the code as well of that specific span creation. In my app.js, let's look at emit span. So I'm grabbing the context. I'm creating my parent from the current context. I'm creating a span as a child of that parent. And then within that context, I am setting the action to action. So that action that was passed to my function was click from this specific button name. And there we go. That's what you saw, manual span, user clicked button 1 emitted. This is that right there. And then I called subfunction just to make it slightly more interesting and see a little bit of a waterfall being created. So this subfunction is just being called, and it's just saying, oh, I'm doing some little business logic here. I'm creating another layer of span. I'm creating another child, and this is my sub key, and this is my sub value, just so I know when I'm looking at my logs or at my traces, like where I am. And that's it. That's all there is to it. And this is just kind of like creating this kind of like a fake data platform. But I'll click on this sub function, and I will see sub value from my sub key. And then one thing that's interesting that I wanted to point out, we now have a parent ID, df09. Now we have its own span ID, and we have the big all-encompassing trace ID, but we also have a parent ID. And I'll look at that, this right here, and we'll look at its span ID, and it is df09. So it keeps track of all the spans above it, and that's really important to actually keep as you go along through your span travel. This is just the beginning, right? It's going to go through your backend. It's going to go through some validation. It's going to go through all your different services. So it's going to create a very long history. And so that's what is being created here with the span ID and trace ID. Okay, and to continue along, I want to show a little bit more enhanced usage. I will go back to my app.js, and I will unlock some registrations here. It's in telemetry. This is the boilerplate code to get everything started. To get just the browser running, you are going to need quite a few pure OTel packages. When I told my supervisor that I'm creating this talk for just the browser and just go completely vanilla, they're like, why would you ever do that to yourself? It's like, I want to know that we can do it so we can share it and get other people to do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, just 10. Just 10 packages. It's not a biggie. But I'm glad I did this. This actually now sets up my vanilla front end is the name with a web trace provider that gives you all the basic details of what you're creating. Adding a span processor, this is dictating where you're going to send your spans, how often, so if you're going to do it in a batch to save some time. Do you have a question?
I might have missed this just at the beginning. Can you just briefly explain the usage of the word span? Is this HTML spans, or is this just any element that you've just targeted for observability?
Yeah, good question. So a span is like one action or one stroke in a larger overall activity. So a trace is like a trace is a train, a span is a train car.
Awesome.
So something activates on something else, something happens, something here.
Cool.
So click a button, go to a website, call my database, validate the data, pull it back, send it back. That's like 5 or 6 different spans.
Thank you.
Yeah. Good question. So this right here is saying, I want you to send my traces to localhost 8123. That's my Nginx server. So it'll go there, add the cores headers, and then send it to the collector, and then send it back. And then we have, here we go, the instrumentation settings. Right here, register instrumentation. So I'm going to add the Web Vital instrumentation that I talked about earlier, and then get web auto instrumentations. So that's going to add some functionality to my observability. Let me create a manual span again, and let's see what has changed. I'll look at my observability here. So go back to my list of transactions. Now we have user clicked button 1, and we should see something that happened. Oh boy. Demo gods. Play nice. Okay, let's add. These are my settings where I'm saying I want you to do specifically instrumentation fetch and instrumentation user interaction. So I added those in. Let me interact with my website. And I'll do a simulation of downloading 3 items from HTTP bin. So this called a fetch and an XML request and another fetch, all within one function name. So that should give us some interesting stuff to look at. Oh no. Sorry. This is supposed to show some newly named spans because I turned on the automation. But let's do one more. I have a little weather API call. So let's look up Bellingham, Washington. This should trigger some interesting span. There we go. It's a beautiful 52 degrees. Looks like something did happen. There we go. So let's user clicked. Oh. What are the odds of that? Okay, well, it looks like my spans, of course, are not recording as I'm doing them live and unleashing all those different packages. Ah, there we go. There was a delay. I should have recorded that actually in one of my spans. So here's a click. This click was recorded from my user interaction instrumentation. Oh, here are all the rest of them too. Nice. All right, so you see here, this was the weather API call. So here's my click span event. This is coming free from auto instrumentation. It's saying you clicked a button, and this is the XPath. So at ID get weather was the ID of that button that I clicked. And then timestamp, all that basic information. You do get a little bit more with auto instrumentation. So you'll see a little bit more of the URL that it was sent to, what schema, what port, things like that. Also, it should show you if it was a success or error, you'll see right there, along with the timing. And then this is the automatic weather API. Now that automatic prefix is me actually doing the span method customization. So this is me taking automatic instrumentation and injecting my own manual span manipulation. So it's kind of hard to see here. I'm big in. But I am pulling out query parameters and data from the API return from Weather API. So I'm grabbing the user agent, what they put in, so Bellingham, Washington. Then I can actually enter location country, location name, location region. Interesting to point out, I actually added dots in there because I pulled that out as an object and I was setting it using dot notation. In order to be well-rounded and consistent across vendors, and for all the vendors to work friendly, we have to adhere to a schema standard within OpenTelemetry. They'll try as hard as to automatically do it with you, but that's what we have. We donated the Elastic Common schema to OpenTelemetry to actually use because we've used logs and things like that for so long, Logstash. So. And that's basically the little website that I created. It creates those different levels of manual, automatic, and hybrid. Automatic pulled back with a little bit extra manual. Okay. That was a lot, but you can use it and you can integrate it into your website. Should you do that? No, probably not. There are very good pieces that you can use if you're in a very strange situation. I'm going to guess that everybody has a service or an application that has a bit of a nuance. Well, this is perfect for integrating telemetry into that nuance. So look at it, definitely adapt from it, but if you're going to do front end, Next.js, React, Django, Flask, all the big heavy hitters have OpenTelemetry integration. So definitely use that. But also if you're doing some very interesting front-end shenanigans, check out this repo. I did a lot of the painful stuff that you could possibly use. So it took me a while to kind of figure that out. But I'd be so tickled for you to actually find some useful bits from this. So to recap, observability with OTel in the front end is awesome because there is active support for most common frameworks. Those frameworks are donating their effort and work to contribute to OpenTelemetry because it is an observability users market right now. I work for a big platform, a big data platform. We love OpenTelemetry, and it is in our best interest to play friendly. In our best interest to actually, create a lot of opportunity for you to grow with us. It does complete the journey of your application's usage path. So doing nothing but backend is going to give you a big blind spot to what's actually happening with your user. There's no tethers to third-party applications. Slap on another logo on this slide deck, and it'd be totally fine. I wouldn't like it, but you could. I'm not going to fight you. And then most, if not all, of the third-party services you use support OpenTelemetry clients. So again, Redis, MongoDB, any of the other third-party vendors, the data platforms, you're going to see their name is known within OpenTelemetry, and you'll see a database is going to get the database icon, the API is going to get a little API icon, things like that. And then RUM is rolled right into the process. So if that Web Vitals, you're going to see more and more of those packages popping up, and that just gives you, one last thing I have to integrate for this talk. I wanted to show you the RUM trace. So remember when I was saying longest contentful paint, and then the CLS, like how much your eyes are jostled, and then INP, how, that delay and things like that. This is just another thing that you can get with RUM. This is RUM. My website loaded very fast. I have very minimal CSS. But yeah, 0, 0, 0 across the board. So integrating real-time user monitoring is just adding another little package. So, all right, that is potentially all I have to share with you today. But yeah, thank you very much. Check out that repository. It's going to walk you through the entire process of getting this up and running. We have an example collector, which is just a simple YAML file that you can check out. It connects to Elastic, but you can definitely collect it into any backend that you choose. It also has that Nginx server set up so you can actually avoid cores, collisions, things like that. And then, yeah, the front end has a lot of code that you can lift up and move to any other vanilla service for your browser. So, yeah. Does anybody have any questions?